For my final year project in my mechanical engineering degree, my group designed an autonomous robot guitar that could play literally any song you want, as long as you have the tabs for it. Why build such a thing, you may ask? Well, I could say that there's a market potential for this, but honestly, it just sounds cool, so why not? We were given 8 months to complete the project, which included making the actual robot guitar and writing a detailed report. So in this video, I'll show you our journey of how we built the coolest, cleanest, and cheapest robot guitar in the world, currently. This is not the first day of our project. Let me introduce to you our group members. First of all, you have me, then you have Alif, then you have Julian, Ain, and Danish. So basically how we're doing this project is we split it into 3 parts. First is the picking, and then you have the fretting, and finally the control system. So the control system is what will integrate both parts together and to synchronize the playing and everything. We hope to produce a fully functional, autonomous guitar prototype that can play a simple song, kind of like a finger-picking style. We then searched the internet for some inspiration and created a list of all the robot guitar projects available, listing out their features and pros and cons for some of them. Our robot guitar needed to be user-friendly and affordable. This meant no bulky and complex designs, while ensuring it looks visually appealing. Ultimately, we decided on a design where one string is assigned one actuator, and each fretboard note is also assigned one actuator, because this will allow the robot to play fingerpicking and fret the strings almost instantaneously. Before we can create a picking system, we need to measure how much force that it needs. What we planned to use was a force gauge here. Our plan is to move this mount up and down. You can find how much force you need. For the first prototype, this is what I have. Essentially, it is 6 servos mounted on a support structure that is above the sound hole. Each of these servos, a pick will be attached to them and they will move like this in order to pluck the string. By the way guys, we have a budget of £2,500 for our project, so it's 500 per person. Julian has used up most of our budget. He bought himself a nice SD card for his own personal use. JK. To select the best actuator for picking, we did a bit of math and analysis based on a few criteria. Turns out, micro servos were the best simply because they were cheap, light, and easy to use. To manufacture the picking system, Ain and I went to UCL's workshop to do things like laser cutting, drilling, and 3D printing. This is our first iteration of the picking system. You can see from the video that it doesn't work well because of 2 problems. Firstly, the pick tends to move up and down because it isn't secured tightly. Secondly, the pick holders tend to deviate from being parallel with the string because it's not rigid enough. To fix the first problem, I redesigned the pick holder into this. The spring ensures that the pick returns to the same height after each plucking, while the screw allows me to adjust the height of the pick where lower position equals higher volume. To fix the second problem, I redesigned the support structure from this to this. The pick holders are now supported at both ends using Lego axles, ensuring alignment with the guitar string. I also moved the servos to one side for better wire management. Meanwhile, Danish and Alif were working on the fretting system. They also conducted a force test and found that 5 newtons of force was required. Then they decided that solenoids were better than servos based on these criteria. This is a solenoid housing that they 3D printed. To control the solenoids, a motor shield is needed which basically protects the microcontroller from high power input required for the solenoid. However, they couldn't get it to work, so in the meantime, they used a breadboard. Meanwhile, again, Julian was working on the control system. His initial plan was to structure it into 3 layers, namely application, song, and control. Application is where users can select, start, and stop a song on a touchscreen. Song is where the pre-programmed song file is loaded and then converted into actuator commands. Control is where the commands are buffered before finally being sent as PWM signals to the actuator in order to move it. Julian started off the control layer by writing code to control 1 servo before moving on to 6, which allowed him to execute a strumming action. Alright guys, this is one of our weekly meetings. So right now we're testing the servos.
I'm gonna make it late.
Bro, nasty work. Nasty work.
It looks cool, bro.
Our first hour of 100 hours a week.
We realized that using solenoids creates guitar tapping, which sounds like this. Since we want normal fretting with no tapping, our solution was to place a dampener at the end of the solenoid, so we used flexible 3D printing filament. Also, remember how I said this? Then they decided that solenoids were better than servos. Well, it turned out to be more difficult than they thought. While the design showed promise, implementation saw many challenges. For example, the strings kept buzzing due to insufficient force applied. Inability to tweak force output leading to the buzzing and tapping, as well as increased power consumption if larger solenoids were to be used. Therefore, the fretting team pivoted to using servos because of its greater force control and simpler electronic integration.
I'm bringing mine tonight as well.
Oh shit, really?
Not for recording.
2 weeks later.
Out of like the YPLA, bro.
This new design uses plungers attached to servos to push down on the string. The whole thing has 12 servos covering 4 frets. But wait a minute, doesn't 4 frets require 24 servos? Nope, not if you're smart like Alif and Danish, whose idea was to use one servo to cover 2 fret notes due to its ability to rotate in both directions. Back to picking system, I used acrylic instead of plywood because plywood tends to warp and make the alignment inaccurate. I also added some extra space for the Arduino and the servo driver board to sit.
Okay guys, we're at Henry Moly. We are testing this picking system right now. A problem we had just now was it was not moving together at the same time. It turned out that it was because we connected the power supply to too many. Yeah. We chained it too long.
It's probably...
Yeah, so now we did it directly. Put the guitar on the floor.
pretty cool.
It's moving
Can try your
together.
phone.
We were also supposed to use the servo driver, but we instead used the breadboard.
9th April today.
It's 9th April.
What does that mean?
It's an auspicious day today. It's the day that we are able to make the picking work.
Okay, here are 3 strums.
Oh, let's
For
go.
you. No, it's 1 strum.
What the hell? Let's go, bro. Go. Lihai.
Oh my god, that felt so good.
What do you feel?
Alhamdulillah.
Wait, I'll do it again. Can you try and G?
Oh, let's go. Damn. Come on, one step closer to success. It was done before we made the test. Yeah, I mean, I hope you don't mind. Fast station. I would say this is one of the best restaurants around UCL. Bro, do you agree?
It's right in front of UCL, so it's very convenient.
Yeah.
And this holds a lot of memory for us because we always
True.
go here after scenarios.
Yes.
This is Julian's one. Very delicious.
The pistachio pasta and prawn.
Tarakimasu.
The smell is so good though.
We are nearing the submission day. Today is the 1st of May, and we submit our report 9th May, and our presentation is around June. So let's see what we have progressed so far.
So we have the picking and fretting system, but how are we going to power it? We can't just wire everything together and turn on the switch. We need to make sure each component gets the right amount of power using suitable wires and a fuse for safety precaution. The solution is of course a power supply. But how much power, voltage and current? Okay, lock in. So we have to power 18 servos, a Raspberry Pi, an Arduino, an LCD display. Each component requires around 5 volts and they will be connected in parallel. Therefore, our max required voltage is 5 volts. Now taking the max current draw for picking and fretting that we calculated behind the scenes, we multiply that with 5 volts to get 39 watts. Considering these numbers, we found a suitable power supply that also converts AC to DC and is voltage adjustable, and then we found suitable wires with a sufficient current rating as well.
And this is a power supply situation. So we bought a power supply which connects to the servo driver, which connects to the picking, connects to the servo driver for the fretting. So simple one.
So now it's all okay, right?
We're basically done with picking and fretting. Now we're left with control system. While Julian works on refining the final software architecture, Alif and I coded some songs in the meantime using Arduino IDE by writing out every single pick and fret action with the appropriate delays.
Today is the 28th of May. We have another meeting, FYP meeting at my house. For now, Julian and Alif are here. Julian brought some snacks. Alif has been here since last night. He did go home. His home is just next door. Basically, we think we can play the full song today. Today's the day,
We say
guys.
that every week.
No. Today is the day.
Yo,
What's up, bro? With my housemate.
it's
There's a party here. Damn.
yeah.
What? What is sounding weird? It's definitely playing some notes wrong. Let's go. We did it, guys.
Then strum twice and then
Coding a new song.
strum
Twinkle,
twice,
twinkle, little
C,
star.
strum
Damn.
twice, again, yeah.
Didn't know
But you
were
can also
codable.
add variation. So this is what we're gonna call the ninja fret. So you know when you play guitar and then when you're fretting, when you push it so hard and you just release it, you make another note. So this felt pads are meant to solve them. I'm using Sony.
I just bought this thing and brought this from my house for drilling the beds to attach the housing.
To attach this thing to
Is this your
the
mic?
housing. Look at all the songs we have. Okay, well, this is the last testing before the actual presentation and prototype, which is in 2 days. So we are setting up the housing right now.
How are you feeling, Julian?
Feeling good? We're gonna ace it.
Yeah.
Like
It's
a
the
show.
Here we have Nazmi showing off his impressive dexterity and hand-eye coordination skills. The only one in our group who is able to screw that nut onto the ball.
That's why his email is nazmi@gmail.com.
No one else would be able to do that except Nazmi.
nazmi@gmail.com. Nazmi.
So I'm the GOAT, guys.
Just in time for Idol Adha, bro.
As you can see, mine is clearly struggling. Nazmi is
Nazmi's magic touch.
This is our updated housing. Arduino, servo driver, cable management, newest fretting design. Look at that, embossed. Legend.
Legendaries.
Legendary.
Wow.
Nice.
Your flipper.
okay.
Sorry.
What did you do?
Did you say your name first?
Yeah, just say our name first and then this is what?
Okay.
This is what song?
Hi, I'm Ain. This is Espresso by Sarpina Cafe.
Hi, my name's Danish, and this is Best Friend by Rex Orange County.
I'm coding a song.
What song?
Here Comes the Sun.
Here comes the sun. Do 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 do. Did he actually teach you how to upload the songs and
Yeah, but I low-key forgot. I mean, I took it down, but I just wanted to make it funny for the video.
Oh, nice.
Well, best friend already have 3 views.
Probably 2 of them from me.
This is looking for songs for us to code because we are engineers.
Engineer. Very engineering-like table.
You gotta catch this software engineering. You're working me to the bone.
Let's kill this.
Okay guys, we are done with all the recordings. We're gonna leave this place. Tomorrow, practice presentation, and the day after is the real thing. Less than 18 hours before our presentation. Doing our final practice run at Henry Molly again. And Ayin just arrived. She's very late.
No!
Are you just 3 hours late? Oh my god.
I am Ain. Today we're going to present our design project, Autonomous Guitar.
Why is it?
I am at Muhammad Thumbul's house.
Muhammad Sumbul.
We are doing our very last minute preparations and corrections and additions to our presentation and also our prototype demo. So a few things we needed to do, like record more videos, testing. Alif is also, he added some FEA stuff, very last minute.
Show them.
Without even telling anyone. Legend, bro. Ooh, look at that, safety factor. This is very technical, guys. Now we are waiting for, what's the other cat's name, bro?
Khalid Kashmiri.
Khalid Kashmiri, aka Danish. You can see I'm using a spatula to screw because I forgot to bring my tools. Engineer.
240 BPM. We're playing a 30-second note.
30-second note.
Yeah. You want to hear it?
Yeah. Damn. I heard all of those notes, bro.
You're just too slow. You can't hear it, but we can.
Yeah.
Bruh. First, e-bike sharing. Scan QR. Wait, how do you control the speed? Kinda scared, but kinda excited too. Yo! Okay, go now. That's actually so fun. UCL Student Center. Nice and easy. Specifically, the Student Center.
7 hours away from our presentation. This is our last time in the student center printing stuff.
Last time doing anything at UCL.
Alif just spent 30 pounds on printing. Like more than 100 ringgit, just paper.
Yeah.
Color on paper, bro.
87 pages of colored paper.
Let's go. Turns out, black and white.
It's done. Oh, it's thick, boy. Whoa.
Ew.
Guys, we're cooked. It's 5:21. At this rate, I think we'll be home by 6 something and I'll be on the bed by 6:30.
Which is the time you're supposed to wake up.
Okay, I'll give myself 15 minutes of sleep. I'm right on your tail. Hey, Bising.
Get out the way!
Nice. Okay. Time for my daily 5 km. This is the Ashton Hall routine. I'm leaving these two in the dust.
So that was
Mine is 2.27. See you guys in a few minutes or hours. Morning guys, going to take the tube to Stratford and then UCL East. Let's go!
This is an Elizabeth line service to Shenfield Liz, Liverpool Street.
Which one are you looking at?
Based on our pointer.
yeah, so that's why I have to wear this.
Handsome lah.
I think you will be a good salesperson with this.
Handsome. By the way, we just finished our presentation. Woo! Yay! Let's go! Now we are left with a prototype demo where we present to a bunch of normies, right?
Normies. I thought we were free from this presentation shackle. Apparently, we're still here.
We haven't uploaded our slides. Food is here. This is the chicken taco, flatbread chicken, and this is the prawn taco. By the way, we got froyo from, I don't know what's the shop called. What berry?
Pink.
Halle Berry?
this is our supervisor. Yeah.
Need tightening up here. Anyway, congratulations.
Thank you, bro.
You worked really hard. I'm really proud of you.
What is that pig?
Yeah, wait, Nazi.
Did you use real pigs?
Yeah. Yeah,
You
real.
then cut.
Yeah.
Oh, mate, this is cool.
Alright, I'll tell you Hey guys, we just finished the prototype assessment. Mr. Alif was the CEO yapper, answering all the questions. I only just talk about the initial stuff. Basically, Alif carried lah.
I'm sweating, you know? Damn.
From all that carrying.
Alright guys, it's a wrap. It's a wrap. What now? What now, guys? What now, bro? We are supposedly inside the cafeteria. They told us they're gonna have a award ceremony, probably. But now we are just munching on some scran. Sandwiches, chips. I mean crisps. Crisps.
You stood up to the challenges today in amazing style. Great presentations and great demonstrations. Give yourselves a round of applause.
Bro, I haven't ever recorded a video of actually explaining how the guitar works, man. Can you do the honors?
This is the overall guitar system. It has 2 mechanical actuation units, which mimic 2 of the different human hand movements on the guitar. This is the picking unit, which plucks the strings in order to make the sound. And this is the fretting unit, which pushes down on the strings on the fretboard to change the pitch of the sound. And this is the control system, fully done by this guy, this king right here, Julian Tan, which causes these 2 to actually actuate in sync. Synchronization, significant, innovative,
Novel,
original, all of that. It sends signals, synchronized electrical signals on the back end in order to make these 2 actuate. They manipulate the guitar strings and create music.
If you want more detail, you can check out our link to the to our presentation slides in the description below.
Oh, in the description below.
Also, check our poster in the description below.
Our 2-hour live stream of our day today, when we presented to everyone except the panel, because that's when we cut it off because it was graded. In the link below.
Any last?
Basically, you can find everything in the link in the description.
Okay, any last words?
I'm so glad it works.
Oh,
Just 2 screws.
damn, bro. I was gonna say, what's your last word, bro?
I just want to say, I love all of you guys.
I love you too.
Seriously.
We all love
Deep
you too.
within my heart, I love all of you guys.
Any last words, bro?
I'm too tired.
Alright, bro.
Bye everybody. Make sure to like and subscribe.
This degree isn't about the piece of paper at the end. It's all about the friends we made along the way.
See you guys in September.
Absolute cinema, bro. Okay, seriously, bye bye.